Hi, my name is Neldo Delgado Aparicio. I will be doing the final project presentation for my group, and this name of this presentation is called the Portable Solar Power Bank for Sustainable Energy. And let's see what we did in this project. Okay, so again, the name of the project is Portable Solar Power Bank with foldable solar panels for sustainable energy storage. I know it's a long name, but it describes exactly what it is. The other partners in the project that collaborated are Nicholas Noel, Andrew Doyos, and myself, Neldo Delgado Aparicio. As you can see, we have the final prototype here, but we'll talk about that later. First, I want to talk about why we did this project. The reason that we did this project is because we wanted to find some sort of energy to charge our phones going off grid. Specifically for going camping, since there's not outlets out there. So we wanted to find something that would charge our phones, store energy, and also have a source of light as well. Again, we did some research for several things that we needed to do this. We were debating whether to do monocrystalline or polycrystalline panels. We ended up going with polycrystalline just because they are cheaper. But for future reference, for more efficiency, monocrystalline will be more energy efficient when it comes to saving space. As far as battery selection, we did 3 series batteries connected. In terms of the charging the batteries, we used a protection circuit module, and we're gonna see it right now. So let me just go over that. Oh yeah, but before that, let me explain how the cost. So we had 9 polycrystalline solar panels. We had, again, the 3 batteries. We had a battery holder case, the protection circuit module to protect the battery, so it doesn't overcharge or it doesn't charge the batteries at different levels. So that is very important to have. We also had an MPPT charge controller. We use this to maintain a stable voltage coming from the solar panel directed towards the step-down converter. That way there's no too much variation, or we have a constant voltage in this case, which is necessary to charge your phone. We have a battery indicator. We have the step-down converter. We have the USB Type A output, USB Type Micro B output, USB Type C output. We bought 3 different colors of 20 gauge silicone wires. We have solder wire. We had HVAC black duct tape, which is actually weatherproof, to use. So this could be a durable project that can sustain the outdoors and, possibly rain and any weather that might be out there. To case it, we use PLA filaments. So we 3D printed the case. We have switches, of course, and then we also had 5 diodes to control the flow of the current. So in total in the project, we'd spent $73.55, which is not too bad, especially for all these variety of outputs. That is not something that you normally see in the market. Okay, now as far as the actual diagram, this is the final draft of how the electronic works. So we have the solar panel over here, and we obtain the energy from the sun. The current goes through the diode to prevent the current from flowing back. It goes into the MPPT. The current from the solar panel, it has an average of 15 volts at any given time. So the MPPT, it transforms the 15 volts into a constant 12.6 voltage in order to charge the batteries. So the current goes out into another diode to also prevent the current to go back to the MPPT. The current goes down. It connects to the PCM, and then that charges the battery at a controlled level. So from the PCM, we connect the power to the two features that the prototype has, which is to charge the device that you want, depending on the output that you select, or to turn on the flashlight, the 9-watt flashlight. We have a switch here to determine which feature you want to use. We have LED, off, and then charge. And then finally here we have the battery indicator. Okay, so just for a quick glance, this is the MPPT. This is the DC converter. These are the three outputs. This is the flashlight. It is 3 strings of LEDs, and it's in a set of 3 sets of those. So 3 sets of 3 strings of LED, and each string has a resistor connected to it of 130 ohms. And then we wired that. We did that handmade. Here's the indicator of the battery to see how much battery we have. Here we have the PCM, which controls the current to the other devices. Here we have the battery. Okay, and that's the solar panel, how it folds. This is the design for the case. We have the lid, we have the bottom, the hinges, the handle. Okay, so as far as the analysis and results and test, the solar panel was expected to have a 15 volts output under sunlight, and the average did come out to 15 volts, which matched our expectation. The current expected out was 500 to 600 milliamps. The average was 430, which was slightly below the expected, but is still acceptable. The battery capacity was 12.6 volts and 2.6 amps per hour at full charge, which was the measured outcome, and it met our expectation. The flashlight had an operation time expected 3 to 4 hours. the outcome was 3.8 hours, which matches the predicted runtime. The USB output voltage expected was 5 volts. The measured amount was 5 volts, which is the acceptable margin rate. Now the USB margin current, we were expecting 500 milliamps. We only got 150 milliamps, which was underpowered. And the phone charging duration, we expected 2 to 3 hours for a full charge. The outcome was that it was up to 8 hours. So this is, of course, inefficient, and we'll need modifications for the future in this project. So this is the final prototype. So we printed the handle. It has some hinges. We made the color white just so that it will reflect the sunlight, and the components on the inside do not get overheated. So the first thing that we have here is that double switch. So when you click forward, it would turn on the charge. When it's in the middle, it will be off, and then when you click the other side, it turns on the light, and I'll show you that in a second. Here are the lights. So just a quick presentation. They are really bright, so it is great for the outdoors, so very useful. And then on the backhand side, we have the battery indicator with the switch. So you just switch on to see the battery, and then just switch off when you're done seeing it. All right, so next we can open up the prototype. So as soon as we open it up, we can see the 3 outputs. So we have USB Type A, USB Type C, and USB Micro B. So depending on what you want to use, you just use whichever one you want. And on the right hand side, we have the foldable solar panels. So we would just take it out wherever we're at, and then we would expand it just like this. So we chose to make it foldable, that way it can be very compact and be able to harness as much sunlight as possible. The solar panels, each panel is 5 volts with 200 milliamps. We connected 3 panels in series, and then we made 3 sets of that connected in parallel. So in total, the combination of all the panels is 15 volts. 15 volts and 600 milliamps of output, which is 9 watts. So finally here, in case we do need to make any modifications, this can be taken off, which is held by these magnets right here. So here we have the flashlight. Here is the MPPT. Those are the diodes. Here is the PMC that controls everything. Here is the switch that I was talking about. And just to show you, when we want to charge it, you press left and it can actually show us what is the output of that voltage if we want to double check that. And if we do need to adjust it, we can turn the screw right there. for future modifications. Over here is the battery indicator, and that's pretty much it. Okay, so I was able to find that cable to charge. So let's plug in this into USB type A, and then I'm just gonna charge this cordless mini grinder that I use for the project. So I'm gonna put that here, and as you can see, it is charging. And that works perfectly. Now the output for all three outputs, it is 5 volts. However, the current is only about 150 milliamps, which for a phone it can be not too fast of a charge. So instead of taking 2 to 3 hours for the phone to fully charge from 0 to 100, it can take more like 8 hours. So to finalize, here are some things that we could have improved for the future for this project. Any modifications? So upgrade the buck converter to a higher current, like a 2 amp to 3.3 amps. Add a support for fast charging. To use, like I mentioned before, the monocrystalline solar panels. To add a microcontroller with a display to show the live data of the solar panels. That will be very convenient. Design battery section to be modular or swappable to allow capacities for easy upgrades. To add ports to connect external solar panels for faster charging, or even to just to have an input so we can charge the prototype with an outlet rather than just charging the prototype with solar panel. And that is pretty much it. This is our final project. We hope that this will be useful for the future, to whenever we go camping and we're able to have our phone charged in case of, an emergency or anything like that, or just to have a source of light. And yes, that is everything. Thank you for watching my video and have a great day.